question that the problem I want you to cover is to basically do a level by level traversal of a binary tree. Do you know how you roughly define a binary tree?
Yes. So I just print out all the node value, right? And don't do anything else.
Yeah, you just want to print out the values.
Okay. So we have the BST nodes, right?
So they're not binary search trees, they're just normal binary trees.
Oh, okay. We have tree nodes.
Okay.
We have key. Do we need a value? I don't think so. It's not necessary. Key equals key. And then left, right equals, this is the tree node. So
okay.
We will, so I would use level order traversal, right? So
yeah,
I think I will
do.
Yeah, I will use a BFS. So basically you have a node, right? And then you just add the neighbor, which is left and right child, to a queue.
Okay.
And then you're popping the queue like one element out of it at a time. Like every time you pop the top of the queue, you add what you're popping into a result array. And then
right.
what you're popping, you keep adding the neighbor back. So this is basically BFS, right?
Right.
Okay.
Gotcha. Okay. I think that sounds like, pretty there to me. I think we can go ahead and, skip coding this one. Let's, change it around a bit. So let's say I have a tree, right?
Yeah.
And this is my tree. The 3 is a right subchild of the 4.
Okay.
I have a 5. Okay, I have a 2, 6, and a 7, right? And instead of doing level by level traversal, where you'd print the 2, the 4, 5, 3, 2, 6, 7, we want to do a vertical traversal, right? So then what you're going to do for a vertical traversal is you're going to print off all of the values, in order that match, some vertical, some left to right depth, right? So we can imagine this as being 4, 2, 3, 2. I believe that's it. Wait, let me see how this goes. So 4 is 1 to the left, right?
Mm-hmm. Yeah.
Yeah, it should be 2, 3, 2, and then you have 5, and then 6, and then 7. I think those are the unique depths.
Yeah. I see. So let me just try to see. So 2, 3, 2. Basically, the 2 should be here, right?
Yeah, that's kind of how it works out.
So if it have the same same horizontal value, so to speak, what should be the orders? For example, 2, 3, 2. So if the horizontal value is the same, we print them in the order of the depth, right?
If the horizontal, you will be printing them in the order of the depth, yeah.
Okay, so basically this is So we can decorate, like augment every node of the tree with 2 value, right? One is like, just call this like h value, horizontal value. So basically,
Okay.
the root h value is 0, right?
Okay.
And the root is left trial is the current value minus 1, right trial is the current value plus 1. So we have the h value for all the nodes. We keep track of the depth, right? So the root is 0 and the child is plus 1. So after we have augment with all the value, actually, while we are augmented, like we traverse the tree to augment the value, right? We have a dictionary. So basically, state dictionary maps. First, we have to like h value, right, to a list list of like pair where it is like depth to node, right? So
Okay.
we partition the entire tree according to age value first. The one with the same age value, we sort them. Well, actually, while we're adding them, it's not necessarily sorted. We have like a list of depth to node, and while we're done traversing, we sort every list with the same age value, and then we just iterate through the keys of the dictionary, which is age value, and then
Right.
just return the sorted list. So basically, just keep track. Like we know the age value and depth of all the nodes, and then we just print them out. Right.
Right. Okay. Yeah, that sounds pretty okay to me. But one thing you mentioned is that inside of your list, or inside of your map, you're gonna have, both the depth and the node itself, right? So
Yeah.
is there any way that we can kind of, avoid doing multiple traversals?
Multiple
'Cause yeah,
traversal.
is there a way that, you could maybe have the traversal happen such that the depth is in order?
Yeah, we can just we can just fix the like use proper order, proper traversal order. We can visit the current node and then the left and the right. So like the smaller depth will come first, right?
Okay. So I mean, it's probably related to the previous question we just did, right? Like, there's a name for this.
Yeah, yes, there's a name for this. So would you like like the previous question is that is there a way to do only one traversal? Like the algorithm I previously proposed, I only plan to do one traversal. And then the
Yeah.
second one is that is there an order that we can ensure the depth that is like already sorted when just adding to it? So the answer is that we do uh, we do the current and then the trial, so it will be sorted. So would you like me to implement this?
Yeah, sure. Let's go ahead and do that.
Okay. Um, what's the name? The solution. Okay. Mm, what do we need? Nothing. Okay.
Yeah, you just have the root.
Um, states is a dictionary. When we have augments, but it's another class. Okay. And then
Okay.
what we do when we're done augments, so we'll have a for key in state keys sorted
Okay.
results. So of a list of nodes, so just append state key.
Okay.
Okay, so the augments, if there's nothing to augment, right? And then, actually, I need another parameter, like the begin, like is the h value in the beginning, which will be
Right.
0. Okay. It seems that depends on parent. I also have to have a reference to the parents. Okay, parents.
Well,
Which
that depends on how you structure it, right?
yeah. I can do this. So like in the beginning, like the current root is the roots, but the root is
Hmm.
parent is none. Okay. Um, right. If the parents equals Yeah, I don't need the H value here. Yeah, if the H parent is none, then the current depth equals 0. Current H value equals 0. Okay.
Okay.
Else, okay. Let's see. If node is parent left child, then the node's H value equals parent H value minus 1. Else, node's H value equals parent H value plus 1. Okay.
Okay.
Yeah, this has to have a recursive. So we know we have done the current node. We just yeah, let's see. We do the current node first, and then we do the child. So it's the right order of traversal. Okay, then we have to do something to the states. Yeah. So here we have the current nodes. We do if not in states H value equals empty list, and then H value will be appending the nodes.
Okay.
Let me just check the logic. This, if the node is equals none, return. If the parent is none, if the parent is none, okay. If the parent is not none, node depth equals to parents depth plus 1, minus 1, plus 1. Outside of this, we have the current depth and H value. Then put it into the dictionary. Travel noise state append node. Recurs to the left, recurs to the right. Seems correct. State dictionary reads strike the key. Have this. Yeah, I think this looks okay for me.
Sure. Let's go ahead and try and run this on some test cases.
Okay.
So you can just include that at the bottom, I guess, if you want.
Yeah, but we, like, in order to run a test case, we have to have a tree.
Yeah.
And then
so
we have to write a class, basically insert all the node, right?
Yep. Yeah.
So I have to write another question in order to test this. So
Well, I mean, it's not another question, but yeah, you could use the tree example from above if you'd want.
Okay. All right. Roots equals to tree nodes. Two. Okay. I'll just name this M1 equals tree node 4. 5. Okay. 2, a little confused up here. 3 is the right child?
Yeah, I think it was originally the right child of that one, and then the 2 was the left child of the 5. I think that's how it was structured.
Okay. Hold on. I think I have to add the value here. Yeah, I have to add the key instead. Okay. 3, 2, 6. 7. Okay. So root left equals to n1. Right equals to n2. And then n1 right equals to n3.
Okay.
N2's left equals to n4. N4 is 2. So 6 is the right child of 5, right?
N5 dot left, I think it ends up being your N2 dot left is equal to N4, right? This is N2, because it's the 5's left is the 2. And then this was originally set up so that it's the 6 over here. So it was N5 dot right.
Okay.
Is equal to, or N2 dot right is equal to N5.
N2 dot right is N5. Okay. N5 is 6. And then N5 dot right is equal to, okay.
N6. Yeah, I think that roughly looks like the tree.
N5 dot right equals to N6. Okay, let me just recheck this wire up thing. Root left is 4. Root right is
right.
Okay, and
yeah, this
1
looks to be okay to me because you have the 5 left is the 2, and then the right of the 5 is the 6, and then the right of the 6 is the 7. Yeah.
Okay, I see. All right. Name. What is this? Oh.
Right.
Cool. 2.
Yeah, this looks like it's exactly what we would end up wanting. So there's one case I was thinking of where this might not entirely work as intended. So one of the things we wanted is to always ensure that the order is correct for how the levels show up, right? So within a single level, the order of that array should be set up such that that part is in the correct vertical order, right? So going from left to right, each of the arrays have the, in a sense, horizontal order.
Yeah.
But then within an array, it should have correct vertical order, right? So
yes.
I think that is one of the things we talked about. So how does it kind of end up working out if you have let's say this kind of array. Let's say, I think it works out if you have like a 5. Let's say that this one is a 3. Yeah, and then you have another, this was the left subchild of the 3. And then let's say you have a 4, crud, this is, say it goes to a 2, and then you have 4 again, and then you have a 5, right?
Okay.
From what I understand your code, because it's just doing a pre-order traversal, you should end up printing off 5, 5, 2, right? But this isn't what we want. What we want is 5, 2, 5. Right?
Oh, okay. So I see. So if like, yeah, there's let me see. Same. Yeah. So I only differentiate between the horizontal value and the depth. So what if they're the same, right? That's what you're saying. If the horizontal value and the depth they are identical, we want to use the level order from left to right, right?
I'm saying if the depths are different, right?
The depths are different.
Because over here, the 5 and the 2 have different depth.
Oh, okay. Okay. Let me see.
And the depth of 2 is lower than the depth of the 5.
Yeah. Okay. Let me. I'm just trying to see why my code will print out 5 and 2. 5 and 2.
Yeah, because
but like
we were recursing.
The 5 is 67, right? The 5 is left child 2, right?
No. The 5 is the right child of the 4 here.
Okay.
So
okay. Yeah.
We go left, right to get to the 5.
Yeah. Okay. Let me just see.
So I guess this is probably easier with the little links. Let's just add those in. Yeah, there's no simple way to do this.
Yeah, I can see what
the
you're
tree,
saying.
right?
Yeah. Because I see. So yeah, this turns out like the pre-order does not guarantee the depth. It's like the depth is So what we can do is when we append here. Right? And then here when we are adding, so sorted, because the depth comes in the first, right? And then here we just need to get rid of the for item in rest. Just need to take this, get rid of the depth, right? This will work because we're not relying on the order. We're just implicit denote the depth.
Right. Yeah, I think. Well, it's what you said. It's just sorted state of key. So I think for actual Python, I don't know if that works out right. Oh yeah, it would, because it's a tuple. So then it sorts on the first value, sorting on the second value. So by default, depth works out. Okay, cool. Yeah. I think that looks fine to me. The only typo is the item of 1.
Yeah.
And you can run this again on the same test case, but you won't have to make an additional test case. So
okay. Index.
Was it not?
Let me see.
2 items each time.
Let me see what's going on here. Depth key. Let me just try to see what is the rest here. Okay.
Right. The item itself is a list, so then you have the
I can't see the right of the screen. This three, where does it printing? Oh, okay, I can see. Oh, I see, I see. It's a list. Yeah, kind of ugly. Okay, right. Temp, temp, res this for item in temps, right? That's going to be a list for node in list for node in list. Okay. Temp to res tuple res tuple temps. Okay. Temps appends nodes one.
okay.
Once you're done, append temp. Okay, I'm just trying to see if this is correct. Tuple list, list, okay? Node in list, node one, temp. Yeah, should be working. Yeah.
Cool. Looks good to me. So the only thing I guess I wanted to cover, you're not gonna have to code this out. It's just more discussion. So, uh, earlier in the first question, we talked about a level by level traversal. Do you think that ends up being helpful in any way for this question? And how?
Yeah, I see. Just think about this for a minute.
So can you kind of see the relation between what a level by level, so a level by level traversal, from what we understood from the first question, it was just going to go through level by level, right?
Mm-hmm.
So, for this question, we want to
We
have the vertical.
can we like first we augment all the node with depth and horizontal value, and
Yeah,
then we do a level order traversal on the augmented node, so that while we're doing level order traversal, we're doing the same thing with the states.
right.
So partition by h value. Yeah, so that way it's guaranteeing that the depth will not be messed up, right?
Right, yeah. So can't we almost replace the pre-order traversal with a level by level traversal?
Let me see.
It seems almost like we don't have to go through twice, right?
Oh, yes. Like you mean like yeah, like the way we do the augment, we can use level order traversal, right?
Yeah, sort of. And if you end up doing that, then you don't need the depth at all as something you
Yeah,
store.
yeah, I see.
And you can skip out on augmenting the trees. for the most part. I think even for your solution, I don't think you need to end up augmenting the trees. Just because you're augmenting it once, and then the only place you use that augmented value is on the next recursive call, right?
Yeah.
So that storage isn't permanent. It's just something you can pass in the next call over. Cool.
Yes.
Yeah, I guess that's pretty much it. I think the code is always the main part, and that came out totally fine and bug free. There are more test cases we could cover, but I'd say it's pretty annoying to do that with the tree, so we can kind of just leave that as is.
Yeah.
I guess for me, did you have any questions?
Oh, how did I do? Like, if it's a real interview, like out of the 5 star, like what kind of score would you get, and like what I can do better in terms of improving?
Yeah, I would say that you definitely did well for communicating out kind of what you were gonna do, writing the code, coming up with the problem approach. The only thing that I would mention is when you start with your questions, maybe it's helpful to instead of diving straight into code or even an approach, you want to make sure that you understand the question so that you can clarify any constraints that there might be. For example, I'd say in a normal question, one of the things you could ask is, oh, am I only working with integers or floats, right? In this question, that's not really relevant, but I'd say in some of the array questions, the common array type questions, that's probably a useful question. For this one, the thing to have asked would have been, how is each vertical section ordered? I think we covered that in the beginning, but I'm not. Maybe it's just past my mind.
Yeah.
Yeah, I
Okay.
think that's what I'd say it went well, and this would definitely be like a pass. So
Right.
cool.
All right.
I
Okay.
guess other than that, did you have any other questions for me?
No, no, no.